Alright, so now that we know how to write a vector in column vector form, we can kind of just do a bunch of mathematical manipulation of vectors. And if we want to, we can kind of avoid the drawing pictures bit. We never want to, because drawing pictures is super awesome, but we can. So here we have three vectors in column vector notation, right? Now think of the number 5, okay? You might have thought of this, but you also might have thought of 5 objects. In any case, you had a vague sense that the number 5 wasn't nothing, but it also isn't an extremely large number. You have a sense of what the number 5 is in your head when someone says the number 5. If I say the number 1 million, you have a sense. You have a sense of 1 million. You know it's a big number. If you had $1 million, you'd be pretty happy, right? What you want to strive for is the same kind of sense when you look at these column vectors, right? So when I look at this column vector, 3, -1, I have a sense that it looks something like that, right? Because it's moving 3 across and 1 down. When I look at the column vector 2, 5, I have a sense that it looks something like that because it's 2 across and 5 up. When I look at this one, I have a sense that it's -4 and -2, so it looks a little more like that. U, V, and W. Having a sense of these means that when we start adding them together and start multiplying by scalars and doing things like that, we won't get answers that are nonsense, because in the same way that if someone said what's 5 plus 2, you wouldn't say 1 million because you have a sense that 5 plus 2 should be a relatively small number because 5 and 2 are relatively small numbers. Something to think about. So with all that out of the way, this is super simple. We have vector u, we have vector v, and we're going to add them together. So 3 and -1, and we're going to add v, which is 2 and 5. And it works exactly how you would think it works. 3 plus 2, and -1 plus 5. 1 plus 5 is 4. And my answer here is 5, 4. Is that answer correct? Because I have a vague sense of things, of what these look like, I can sort of double check that that is correct, because u is 3, -1, something that looks a bit like that. V is 2, 5, something that looks a bit like that. And so would my answer, 5, 4, be that? 5, 4. Yep, that looks about right, so I'm probably correct. Alright, let's look at u minus w. Okay, so we have 3 and -1 minus w, which is -4 minus 2. These are the first ones that people have a little bit of trouble with, but if you're careful, you won't have too much problems. It's 3 minus -4. It's -1 minus -2. 3 minus -4 is 7, and -1 minus -2, -1 plus 2, which is 1. Okay, and then again, you can get a sense of the fact that this answer, 7, 1, is reasonable or not reasonable, right? U is 3 minus 1, W is, got to be careful here, W is -4, -2, so it's kind of like that, but we're not adding W, we're subtracting W. So we're adding -W, so we're adding that, and we end up with something that looks like that. Does that look like 7, 1? 7 across and 1 up? Yep, sure does. I think my answer's right. Alright, so let's do a really quick one. And I'm not even going to draw a picture. 2 times vector u. Super simple. 2 times 3 -1. It's 2 times 3. And it's also 2 times -1. So 6, -2. Okay, no drawing a picture. But we've doubled the length of this, we've doubled the length of this, which doubles the whole vector. Easy peasy. And finally, everything just works how it should work, right? 2 times vector u plus 3 times vector v. So we're going to do 2 times vector u plus 3 times vector v. Alright, so we get 2 lots of 3, which is 6, 2 lots of -1, which is -2, plus 3 lots of 2, which is 6, plus 3 lots of 15, which is 15. And then 6 plus 6 is 12, and negative 2 plus 15 is 13. 12, 13. Okay, that's it. That is some fairly basic algebraic manipulation of vectors in column vector form.